All right. So today I'm going to talk about Chainlink and how to use Chainlink with ArcGIS services, really, and the JavaScript API. If you're not familiar with it, Chainlink is a decentralized Oracle network. So when you talk about blockchains, oracles are a way that you can communicate with off-chain data, right? And I'll kind of go over real quick in a minute about how you think about like regular web stuff and like blockchain stuff and why you need something like this. But it's pretty interesting and it's pretty cool. And it's Chainlink is not the only oracle for blockchain out there. There's a few other tools that you could use that do pretty much the same thing. But the idea is that you have something like what they show here, where you have a smart contract, right? And that smart contract can pull information from somewhere outside the blockchain, right? So maybe get price information, weather information, just about anything. So they got this idea of randomness, which is pretty important when you work with blockchain data. They talk about working with any API. So you could write a contract that makes a GET request to an external service, and that smart contract will go ahead and be able to provide the results from that in some way. There's some caveats to that, things you need to keep in mind when you're working with that. So they've got some really good documentation. Now, I'm not going to go over how to set up a local node or anything like that, because that's it's not involved, but the steps to do it are pretty simple, right? They've got, if you go into node operators, they've got this documentation for set up a Chainlink node. They pretty much walk you through the steps, right? And I was doing it all locally, so I just followed the Debian step. Install Docker. They provide the Docker image for you already. How to set up your environment variables. One thing I will say here, I needed to do this for my local node to work correctly for my custom jobs I was doing. You need to set the minimum contract price to like 0.1 link, right? The default is 1 link, but set it to 0.1 link, or you might get some errors when the jobs start to run. So that's like one tip I will give you there if you're doing this on your own local development server. And I can't remember how many zeros that is. It's like, I think 17 zeros for 0.1 link. And that's another thing. When you're dealing with the smart contract stuff, you don't deal in decimals. You have to deal with significant places, like 1 million, something like that. And then internally, the smart contracts figure out if it's 0.1 link or not, kind of thing. WEI is what it figures out. So yeah, just walk through this. It'll set you up. You do have to set up a Postgres database somewhere. So I just did mine on Heroku, and then you go ahead and need to use like there was another service you have to use, Infura, to set up handling some Ethereum stuff and whatnot. But like I said, it'll walk you through the whole thing. There's a couple of really good videos out there that talk about how to set up a Chainlink node. Okay, so let's go over why you might want to use a Chainlink node and what its purpose would be in your development of working with smart contracts and stuff, right? So here's a pretty poor diagram I made of how a browser app works today. Excuse my use of the cloud for the web here, right? But basically you got some data somewhere, not necessarily just a database, but data living somewhere, and you've got one or multiple APIs that might be pulling information from that data source. And those APIs are exposed to the web, and then you can build your applications on that, right? You bring up something in the browser and you pull information via these various APIs, right? I think that's something that if you're building apps, you got a pretty good, clear idea of that. Now there could be other layers in here somewhere, authentication or mutations of some sort, modifying data, maybe pulling all different APIs in. Ignore all that. Just there's APIs, data, and the web. Now, when we do a blockchain, blockchain's its own encapsulated network, right? It's decentralized, meaning that there are different nodes out there running the blockchain, validating data and stuff. And you write these smart contracts and deploy them to the blockchain. Now, smart contracts by design are immutable. Now, you can provide functions to these contracts. They'll let you update parts of the internals, such as updating ownership, updating price, setting expiration dates, things like that. There's a lot of different things you can do with the smart contracts, but the idea is that once a smart contract is written, you can't change it, right? And these smart contracts have no access to the outside world. They can talk to other smart contracts. So if I know the contract ID for this contract here and I want to use it over here, I can do that. So you can definitely talk to other contracts within the blockchain, but you can't pull any data off blockchain. And you can see where that could be a problem if you have a contract that's dealing with, with prices for, either stocks or crypto or something like that, right? You need to pull information in, or even like during a certain weather events, something like that, this contract needs to adjust some price or something. I don't know. There's a bunch of different things that you can do or that you'd want to do with data outside of the blockchain. So here you have, your blockchain network over here, and then you've got like your APIs talking to your data over here, or pulling data from over here. So how do you get these two to communicate? You do that using an oracle like Chainlink, right? So you can have your smart contracts called jobs that are on the oracle node here in your Chainlink node, and that Chainlink node can go ahead and access outside data this way, right? And another way you can do is you can have custom APIs pulling data in over here, provide a job that will run that API, and then provide a result back to the contract. You could also go ahead and tell the contract that you want to request a certain API, but you want to use the oracle to go ahead and proxy that for you, right? So the oracle is going to go ahead and do the request for you to whatever API you tell it to, and then based on the type of result that you get back, it's going to return it for you. That could be like a uint of some numbers, bytes 32, which I think is a string, or Boolean, right? It'll go ahead and process that result for you. And in order to use this, if you do it on like on mainnet, you pay a fee. You pay like a one link or more fee to be able to use this oracle that's providing access to these different jobs that provide these different APIs. And that could be, like I said, it could be pricing information for crypto or stocks. It could be weather information, or just about anything, right? So that's kind of how this works. This is how you can get the blockchain to talk to the outside world. After you've set up your Chainlink node, one of the first steps you need to do is authorize it to fulfill requests on the network that you're using, right? So you want to be using a test network. In my case, I'll be using Rinkeby. There's instructions in the doc on how to get some Ethereum and some Link into your Chainlink node. So your actual Chainlink node will need some Ethereum. I don't know if it needs Link, but I'm pretty sure it does. So there's some links to get ETH, for example, from some various faucets on the networks that you're going to use. So like I said, I'm using the Rinkeby network. So I've already got some ETH and some Link on my Chainlink node to be able to run its jobs, right? When you do that, you get to this fulfilling request page. This is probably like the main thing you need to do. Pay attention, follow the instructions, because what it's going to do, it's going to have you open this contract, which is going to just be linked via, it's just a gist, and it's going to import this contract in here. And when you do that, you're going to get, you're going to deploy. So you have to have MetaMask. And in my case, I have my MetaMask. It's a development account on the Rinkeby network. I've got some ETH in here. I've also got some Link as well. There we go. So I've got some Link right here and some ETH that I can use for doing all of my development that I want to do, right? So I'm using MetaMask. Make sure you've got in the remix.ethereum.org using the injected Web3, because it won't work any other way. And then what you want to do is follow the instructions to go ahead and authorize your account, right? Or not your account, but your Oracle node. And you get this contract here. Now, this is important. Copy this contract ID. You're going to need this when you're creating your jobs in your node, right? So you're going to set the fulfillment permissions, and this is going to be your Oracle node address to your node, and then set it to true. This is going to allow it to be able to run jobs on the test network, in this case, Rinkeby. All right, so that's an important part. So you do that, and those instructions are all in here, and it's going to walk you through all the steps, right? And you deploy it to the Rinkeby network, which is what I did here. Deploy there, and just like I said, follow the instructions. And when you get down over here, after you've done the set fulfillment permissions, like it's saying right here, then you need to go ahead and add these various jobs to the node, right? You need a job for bytes 32, post bytes 32, ETH 256, ETH UINT 256, and ETH bool. So if you look at these, for example, the ETH UINT 256, it's going to allow certain tasks to run, right? So it's going to have an HTTP GET, JSON parse, multiply, ETH UINT 256, and then ETH transactions. This means that someone could use your Oracle node to have a contract that's going to pull information from the API, and then to get the results, it'll proxy those results through your node, depending on what the result is going to be. All right, this one's good. So basically, it's going to have a function on this contract that's going to go ahead and it's going to want my Oracle address and then a job ID. Right, so let's go ahead and compile this testnet consumer one. Save this. That compiled perfectly. So okay, so I'll deploy it. Pay a little bit of a ETH to deploy that contract. Wait for it to go ahead and show up down over here. Okay, now I need to copy this contract. I need to send it a little bit of ETH or a little bit of link. I need to send some link to this one. So send some link here, and I'll just send one link. That should be plenty for this. Remember I told you that I set up my node to go ahead and handle minimum contract of 0.1 link. So having one link sent to this one's plenty. And I've got a ton of test link, which I wish that was real link, but it's not, just test link. So I'm gonna wait for this to go. Okay, so that's done. So that's ready to go. So now what I can do is I want to get the current Ethereum price, right? So request Ethereum price. I need my Oracle address, which I can get over here. So I can still go ahead and copy this one. Come over here. So that'll be the first thing I add. And then I need a job ID. And I need a job ID that's going to match the result that comes back. Right. So if I request Ethereum price, it's going to be UINT 256 right here. Right. You can see the current price would be UINT 256. That would be this job here. So I can go ahead and copy that. I've already got some jobs that were run and some errors because I didn't know what I was doing when I did this. So cross your fingers, this one works. So let's go ahead and request Ethereum price. Again, you've got to pay a little bit of a ETH for that transaction. Wait for the transaction to go. Let's see here. If I refresh this, I might see a pending. This usually takes a few seconds for everything to run. Okay, so that transaction confirms. That means I should be able to come over here and see a pending running. So there we go, pending incoming confirmations. So this is the current job running, which is basically just gonna run this request here to this API to get the price. And it's gonna pull the USD price, and then times it times 100. Remember that smart contracts do not handle decimal places. You gotta multiply them by certain numbers. As long as you know that you multiply it by 100, then you get the result. You can divide it by 100. Like if you're working with a DApp, a web app that you built, you would know what you need to do with that result at the end of the day. Right. So okay. So we've run the get, the parse, multiply. So now we've going to get the result right here. ETH UINT 256. So now we're performing the transaction. So my Oracle node is performing this transaction to return the result. All right, so let's get that going there. Almost done. Almost done. Like I said, these node requests, right? The jobs that run, I mean, they're not exactly speedy, right? It's its own kind of decentralized network. My node is running this job. But yeah, you see it takes a little bit. So it's taking a little while to get the transaction going over the network. And at this point, my node already has the result. That a bulk of that time was just the transactions over the blockchain, right? So, okay, so that transaction is run. That means that now I should be able to come over here and get the current price. And the current price for Ethereum, it's 2,640 and 71 cents. And I know that because it was multiplied by 100, right? So that is how that would work if I were just going to run the contract to run the job on my node. But I want to take it a step further. I want to run my own API and have it be proxied via my Chainlink node here. Now, how would I do something like that? What I have here is I have a very simple node application running an Express server that is going to go ahead and use a JavaScript API to load a feature layer. And I'll show you the feature layer right here, right? So if I come over to my content, and let's go ahead and go to the actual map here that I made. So what I did is I created a feature layer that's got a few polygons on it, and we're going to try and mimic a geofencing, right? So I have a few polygons sitting here. I just kind of picked some arbitrary areas and drew them on the map. And so yeah, so what I can do is I can go ahead and have a smart contract that's going to take the latitude, longitude, and then ask the API over here, is that point inside one of these areas, right? And then just tell me true or false. Keep it real simple. Remember, when you're doing with these smart contracts and stuff, you want to keep the results as simple as possible. You're not going to be returning back megabytes worth of data, right? It's not like a full-on, I'm going to return back JSON string of like thousands of features or something. Just keep the results pretty simple. Okay, so I've got my feature layer in here. This custom parameters, this is really kind of a nice feature that you can do with the Chainlink request. You can basically say that I have a custom parameter called lat and lon, but I'll accept x or lon or longitude, and the same for lat. I'll accept y, lat, or latitude, right? So it's kind of cool. You can have different parameters accepted in there. So I won't go into detail how this validator works. I'm not even sure 100% how it works, but basically it's going to go in and take my request, and then if I pass latitude or X or Y or whatever, it's going to turn them into the ones that I'm expecting to get, right? So I have a lat and lon here. Now remember I said you have to pass everything over as strings because there's no decimal places. So I'm going to go ahead and convert those to numbers. I'm going to load my layer. I want to return all the geometry. I'm going to query all the features. Then I'm going to create a point from the latitude, longitude that were returned back to me or that were given to me by the request. And then I'm just going to run features.sum. So basically this will go ahead and short circuit the first time it's true. So if the first one is true, that's all I care about. I don't care about the rest of them. So if the point isn't any of the polygons, just make it true. And then I return back my response. So I'm going to give a status code 200. Normally you get that if you use the requester that comes from the Chainlink external adapter to make a request. You'll get the status and everything, but I'm just going to go ahead and make my own since I didn't use that requester. And you need the job run ID. There's a this data property that has my result in it, right? And the result is valid. Okay, I got it. I'm not supposed to put status code, just status, and then this requester.success will figure out what the status code should be for this. So okay, so I've got this running now on port 3030. So it's going to curl a request for that, and it's going to tell me whether it's going to be true or false. All right, so it was false right here. I can see the result over here and over here in my curl request. Now let me go and update it to a location I know is inside of one of those polygons. So it's going to be 042571, and then negative 118.194753. Now this should be true at this point. Yeah, result true. Man, that was fast. I think because I've already requested the layer once, and yeah, I don't know why. I don't know why that was so much faster. I'll do it again. Yeah, look at this. That's the JavaScript, not JavaScript. That's the ArcGIS stuff just being super fast on the back end. All right, cool, nice. If I do the other one again, yeah, false. You look like you just needed to kind of kickstart that service at that point. So okay, so that's my service now. Now, how do I get this service to run inside of my Chainlink node? So what I want to do is I want to come over here to bridges, right? Now I've already got one because I was testing stuff out in localhost 8080, but now I want to go ahead and do stuff on let's see, geofence, I'll call it, and it's going to be localhost 3030. Awesome. So I'm not gonna have any minimums. I'll just do everything at 0 here. I think that's all I need to do. All right. Okay. Create bridge, and we're good to go. So now I have a geofence bridge. Okay, now comes the fun stuff. So now what I want to do is I want to create a new job over here. Let's delete all this. So that was what I was doing before. Now this is so I can test my job. I'm going to run it locally on my server, right? So I give it a name, geofence local, and I give it an initiator, right? And because it's just going to be running on my node, I'm going to run it directly from the node. I'm not going to have a smart contract somewhere else initiate it. It's just type web. And so now this task I'm going to run is going to be type geofence, right? And this task is the name of the bridge I created over here, the geofence bridge. That's what that task is right there. So if I have multiple tasks pointing to multiple URLs, I can run multiples in here and then do something, right? I mean, I don't know why you'd run multiple. I really just want the one. There might be a way to chain a result from one to the other, but I haven't gotten that far yet. I don't know. I'm sure if someone that knows Chainlink better than I do will be able to give you that information. And then I have these different things I can do here. So let's come over to the doc here real quick. So the core adapter. So there's different things you can do with the results that you get back, right? So in this case here, I'm going to go ahead and copy a parameter from my results. So you can look at samples here. So I'm going to do it, run a copy path. This if you're doing it inside the contract to raw, ETH, USD in the last market, right? So you just kind of like the properties all the way down to something. Then the job, you do a little bit differently, right? So you have a copy path here. So if I look at the job I'm doing here, I'm doing a copy path result. Remember I have a data comes back here and I want just the result from that data. So that's where that comes from. It might also be this one here. I don't know, but I think it's really pulling off the data when it does that. So just copy that and return it. So I'm going to go ahead and create this job. Okay, and then click over here to go to my job. And now I'm going to go ahead and run it. So if I run it, I should see this kind of flash again real quick over here. There we go. It flashed over there. The job is running. And I did give it some valid locations. See, I gave it the 34.05271 and negative 118 number here. So let's refresh that again. It should be done by now. There we go. And I can look at the JSON result that came back from that, right? So here's the data result. True, right there. So that is how I got my result back. So that tells me that this does work. So now I need to expose this to the outside world externally so that, you know, other users of my node could use this job on my node in their own smart contracts. So how would I do something like that? So it's going to look very similar to the job I just made, except if we look at like this get bool, right? When I do the get bool, I have this type run log. And then for the params, I have an address. And this is the address to my Oracle contract. And that is the Oracle contract. Back over here. Oh, over here. This one. This one that authorized my node permission to fulfill request. That is the Oracle contract that you want to use over here, right? Okay, so let's go ahead and make myself some more room over here so we can see some stuff. Oh, too much room, too much room. All right, let's close some of these. It's not going to close all everywhere. Okay. So let's come back to jobs. I'm going to make a new job. And I've already kind of got this put together for you with a few other things in place. So let me copy this job here. Okay, so I'm going to call this geofence real because it's now going to be a real exposed kind of a job that's going to be available to the outside world. Type is run log that we saw before. Here's the address to my Oracle contract that is authorizing my node to run on the Rinkeby network. There's my type geofence. And this is exactly what I had before, where I'm going to copy the path to the result. and it's going to get processed as an ETH bool, right? Because it returns true or false. So it's going to be an ETH bool. And then to finish everything, it needs to run the ETH transaction, right? So that's going to run the transactions to make the results available back to the outside world. So let's go ahead and create that job. Okay, awesome. Okay, so now what I have over here is I've got a contract that is pretty simple. It's based off of a lot of the other contracts, that sample contracts you'll see for working with Chainlink. Oh, I just did that. Didn't mention room. Basically, what I have here is a function that's going to make a request for the geofence. So the first parameter is going to be the latitude as a string. Second parameter will be the longitude as a string. And then it does its magic in here to get the Chainlink request going. And I'm going to pass lat and lon as parameters to that. And then I'm going to fulfill that request. I don't call this, but it's going to get called by the contract to pass the result back, right? So, okay, let's get this going. So now what I need, I already have my Oracle contract in here, but I need the job ID for this one. So let me copy that job ID, put this in here. Okay, so now it's going to save this, so it did compile. All right, awesome. That's what I wanted to see. Let's go ahead and find it. So the geofence, let's go and deploy it. Pay him a little bit ETH to deploy it. I gotta wait for that to transaction to get confirmed. I mean, I'm pretty sure this is what like Solidity developers do all day long, just waiting for transactions to be confirmed, right? Now I need to send this contract a little bit of a link, right? Remember I told you before, these contracts won't run if they don't have any link available to run the jobs. So I need to send it a little bit of link. Wait for that to finish. Okay, that's confirmed. So now my contract's a little bit of link so it could run. Okay, I know a lot of steps, right? So the first thing we're going to do, and I'm copy pasting these numbers so I can't remember them by heart. We're going to pass latitude to this request geofence and longitude, which I have here. Okay. Now cross my fingers that this is going to work. So do this, pay my little bit ETH to run that transaction. Let me look at the studio code, see if I can see the results pop over here. So the transaction's still going over the network, hasn't reached my node yet. It will pretty soon. Okay, so now it's been confirmed, so now it should be hitting my node. There we go. So it's on my node. I should see this kind of like flash with new results in here. So this is the old job ID, 4E474, right? Come on. Almost going. Like I said, this stuff isn't exactly fast, but I mean, that's the price you pay for running on the blockchain. Oh, there we go. There we go. All right, there's a new job ID. And so that ran. So it already ran the geofence, it already copied the result, it already ran the result through the ETH bool. All right, so I'm getting a Boolean result back, so now it's running the transaction. Come on, you can do it. So it could be a little misleading because like you look at your node's still running, but the you got a confirmed transaction over here. That was just confirmed transaction that the request was sent to the node, not that the node completed, right? So you do have to wait a bit for this to finish up. And I don't know if there might be a way to get like maybe another property on the contracts you would have that says no job complete and to be true or false. Now it gets set. That way you know the result you're getting is the most recent result. I don't know. So okay, so now this should return true. Oh, look at that. That is super cool. I know it might not seem like a lot, but that to have a request like that run off chain, off the blockchain, and get proxied through my node to get a result back in the smart contract, I think that is super, super cool, right? And getting this all set up, getting the getting a little bit of the nuances of how to get my node set up, how to make sure I was using the right contract, which I had a lot of trouble with. So make sure that I use this contract here for all of my jobs so that everything would run correctly. That was like the trickiest part for me. And then once I had all that working, I had various issues with the running out of gas. We're not having enough link set to run my jobs. The default, like I said, when you create the node, the default is one link for the transactions, right? The minimum. But that doesn't really work very well when you're doing testnet stuff, right? Because I'm only providing the contracts one link, so they really didn't have enough to cover. That was the minimum. So it might use a little bit more, like even if it used like 0.0001 more than a link, then it would just fail, right? I didn't know how to read the logs on the Chainlink node to know why it failed. I had to go to the Discord, which I'll say, by the way, the Chainlink Discord is a gold mine. People there are super helpful. You'll find in the search history probably answers to questions you might have. They helped me out quite a bit to figure out what my problems were with my node, and now I got everything up and running, which is awesome. I'm super happy with that. So basically what I've got going here is I have polygons I created inside of my ArcGIS Online account saved in here. I have a custom API using the JavaScript API to request those features. I take a lat long that's coming from my smart contract proxied through my Chainlink node. I go ahead and check if that lat long is inside of one of those polygons, return back true or false. It goes through my Chainlink node over here back to my smart contract result. Now that is super cool, right? So this was just one example I used of how to do geofencing with the JavaScript API through a Chainlink node, but you could pretty much do just about anything with that, right? So this was just my first foray into working with Chainlink and trying to figure out different use cases I could use the JavaScript API within the ArcGIS platform. And I think there's a lot there, right? This kind of opens up the ability to do a lot of different things. Maybe do some sort of authentication via the node for different parts of the platform that could be used inside of these Chainlink contracts. And I think they call them hybrid contracts because they can do off-chain requests and stuff. Maybe I do something like pass an address, and then I can use the geocoding API in my REST service to find the location address and verify that that location is inside of a certain polygon, like geofence kind of thing, and return back the result. Find how many maybe service vehicles are within a 10-mile radius of that result and return that number back. I mean, there's a lot of different things you can do, right? So I'm just barely touching the surface with this. I'm going to keep playing with it, keep trying it out. I hope you like that. Another way of working with blockchain, smart contracts, and the ArcGIS JavaScript API. ArcGIS API for JavaScript. So if you like that, please hit the like button, leave a comment below, and don't forget to subscribe. Thanks a lot.